Okay, so here we're prescribed an antibiotic, in this example, 500 milligrams every 6 hours. We also know that the half-life of the antibiotic is also 6 hours. What that means is that as it's in your system, your body is filtering it out, right? It's getting used up and discarded by your body. And so a half-life of 6 hours means that if you took a 500 milligram dose of an antibiotic, then 6 hours later, half of that 500 milligrams is used up and it's no longer in your bloodstream. And then after another 6 hours, that would be cut in half again. You wouldn't go to zero, you'd take half of 250, and you'd be down to 125, and so on and so on. So we want to find a sequence that gives the amount of this antibiotic in your system after N doses. I want to give the amount in your system after N doses. So I want to either try to come up with a formula or a recurrence relation. And so we know, of course, that after the first dose, there's 500 milligrams in your blood system. When you take the second dose, that 500 has decomposed down to half, and then plus the new 500 would put us at 750. Okay. And then we come to our third dose. Now that 750 will have decomposed by half. So half of 750 would put us at 375 plus the new 500 dose. So A3 will be 875. And so I'm hoping that you see here that the simplest way to define this is in terms of a recurrence relation, right? We know the initial amount was 500. Each successive amount will be half of the previous amount plus the new 500 milligram dose. Right? And that pattern will just keep continuing on and on and on. Okay. Of course, eventually you'll finish the course of the antibiotic. You're not going to take this forever. You're not going to take it forever, but that's our question: is you find it, and I find a sequence, and so here it is. And the sequence is defined by this recurrence relation. Okay. Now, maybe you could do some fancy algebra with this recurrence relation to try to get a formula in terms of n. Okay. That's certainly something you can consider. Some kind of formula in terms of n that would generate the values of your sequence. Again, I've just written out the first three. Maybe you could write a few more and find that pattern. And if so, cool. Then you could, you'd have a formula, and that would work fine as well. Okay. With this recurrence relation now, we want to ask this question. What does the concentration, should write that twice, the concentration approach as the number of doses increases? In other words, what's the limit of this sequence, right, as the number of doses goes off to infinity? Well, if we had a formula, we could apply the limit to the underlying function, right, like we have done in previous problems. But here we have a recurrence relation. So what we actually do here to work this problem out is we take our recurrence relation and we apply the limit to both sides of our recurrence relation. So we're trying to find out the limit as n goes to infinity of a sub n. So we would apply that to the other side. Limit as n goes to infinity of 0.5 a sub n minus 1 plus 500. Okay. And so we go through and we simplify. So we distribute. Now when we distribute across this addition, because limits do that, we'll distribute across addition, assuming they exist. So the 0.5 will just come out. We'll have 0.5 times the limit as n goes to infinity of a sub n minus 1 plus the limit of 500. 500 is a constant. So now to work this out, what we do is we make the assumption that the limit is actually approaching a value. So we say let L be equal to the limit as n goes to infinity of a sub n. And again, if you started computing values, you would start to kind of see a pattern and kind of get a feeling that, yeah, it looks like it is approaching something. So we start out with that idea. And if it turned out that wasn't the case, we hopefully eventually discover something. So we could take our equation here, limit as n goes to infinity of a sub n, and rewrite it this way as L equals 0.5. And now as n goes to infinity of a sub n minus 1, well, if the original one goes to L, then a sub n minus 1 will also go to L, because n minus 1 will also be going to infinity. So this is actually 0.5 L plus 500. And now we have an equation involving L that we can solve, try to solve anyway. So we subtract the 0.5 over. It gives me 0.5 L equals 500. And so divide by 0.5, and we get that the limiting value for this sequence is 1,000. So we're able to use this little bit of a manipulation here. To get what our sequence actually converged to. Even though we didn't have a direct formula for n, we hadn't taken the time to come up with that. We were able to work it out anyway. L equals 1,000.